Okay, so the next thing we're going to look at is the area of a parallelogram. So we've already looked at the rectangle and the triangle, and the parallelogram is just a moving on from this, okay? And in each of them, without kind of realizing it, we're multiplying two dimensions, and it's always the base by the perpendicular height. But if we look here in the rectangle, we don't call it that. We tend to call this on the bottom, the length along here, which I'll just highlight there in pink. And here we tend to call it the base, which we've labelled A. And here again, we call it the base, labelled A. And each time then, the next dimension we multiply is the perpendicular height, because look, we have a right angle here in a right angle triangle, or in our rectangle, and we call that the width, because we're so familiar with the shape. Here we call it the perpendicular height, because remember, it must come out of that base. And again here, same thing again. We have a base, we can choose any base we like, and then we have the perpendicular height. Now you'll notice these two formulas are very similar. You have the half in front of this because we know that this is half a rectangle, but also we learned, and we saw this before, that this thing here, the parallelogram, is made up of two congruent triangles. So I could very easily split it there and make it into two congruent triangles, or I could split it there and make it into two congruent triangles. So basically, very similar formula to the area of the triangle. We're looking for a base and a perpendicular height, but obviously this time we don't have the half because we want the two triangles that it's made up of. Okay, so I'll show some samples of work and then I will let you work away at those. So for example, here on part 3 of this one, okay, using our formula, so area is equal to A times H. Now notice, so times, when they're beside each other with no sign, we assume it's multiplication. So area here is equal to 15 times 11. And the area there we get is 165 centimeters squared. Now you'll notice there I've used back-to-back brackets for multiplication. Also that can be written like this. Area equals 15 times 11. Okay, but just to get you used to looking at back-to-back brackets. Okay, so the difficulty here in this question is, I'm going to do part 3 again, that we have to realize which measurements we need because we have more measurements here than we actually require. So what we'll see is we need this here is our perpendicular height. So we need the base of that. Now the base of that perpendicular height is here, which we're not given the dimension of, but because it's a parallelogram, we know that if this side here is 5 centimeters, that this side here is also 5 centimeters. Okay, so now it's very simple to apply our formula. Area equals AH. So area equals 5 times that height of 6. So area is equal to 30 centimeters squared. Now don't forget your centimeters squared. Okay, so in this one here, we're going to work backwards because we can see in this question, we're given the area. Okay, so we have to find this perpendicular height. Now they could have put that perpendicular height in here in the diagram, or here, or even here. It's kind of throwing you a little bit putting it out here, but it's the same difference. We had it in triangles as well. Now I'm going to start my formula this time by writing AH equals A, the capital A being for area, because this time I know the area. So I have my base of 6, I have my height of H, so I can just write 6H like that beside each other, because that means they're multiplied, equal to that area of 27. So that means then I need to figure out how I'm going to find what my, I need to solve this for H. So 6 times H is multiplication. So the inverse operation is division. So 27 divided by 6. And that gives me a H of 4.5 centimeters. Okay, now it's only centimeters this time because you're measuring one dimension. Okay, so this question here asks us to find the area of the parallelogram. And then it asks you to then find the value of x. Now, it looks like we have a lot of measurements here on this one. So if we try and match things up. So we have a perpendicular height here connected to this base, which we don't know. We also have a perpendicular height here, and that's connected to a base that I do know. So what I'm going to do is I'm going to work with these two figures first of all to work out the area, because I have all the dimensions for that. And then once I know the area, I can use that same area to figure out what x is, because obviously the area doesn't change. Okay, so the first thing we're going to do is the area of that shape, AH, is simply equal to the base of 22 times a height of 14, and that's coming in at 308 centimeters squared. Now we know if we use the other set, which is the 18 and the x, we still have to get an answer of 308. Okay, so what I need to do then here is I need to times AH equals A this time. And this time I'm using my base of x, my perpendicular height of 18, and that is equal to an area of 308. Now remember, the area is the exact same for both of these. It's just a different way of calculating it. So next thing then, x is then equal to 308 divided by that 18, because it was multiplied up here. So that means x is equal to 17.11 centimeters just.